Welcome to Cheenta School of Statistics and Data Science. Today we will solve the problem number 18 of GATE 2022 statistics paper. The problem says that the x1 x2 xn is a random sample from this distribution, and the chi-square alpha n is denoted by the upper 100 and alpha 1 minus alpha ith percentile of chi-square n distribution, that is chi-square distribution in degrees of freedom, and small x1 up to xn, that is n equal to 18, is a realization of this random sample. Then we have to find the 98% confidence interval of theta based on the sufficient statistics. So let us do the problem. So given that x1 x2 xm, here m equal to 18, it follows IID in the distribution. So the distribution is gamma with gamma distribution. So and notation is defined as follows: the chi-square alpha comma n. We have to find the confidence in 98% confidence interval for theta based on the sufficient statistics summation xi square. So let us find the distribution of y equal to x square. We will need this in next. So by the transformation technique using the Jacobian, we have defined the y equal to x square, and the Jacobian is derivative of root y, that is the inverse function. Here we consider y equal to x square. The inverse function would be x equal to root y. This is defined because y greater than 0. So the by transformation technique, the PDF of y equal to x square would be the value at the value of the previous PDF at value root y into the Jacobian. So this come out to be 1 by theta e to the power minus y by theta for y greater than 0, and this is the distribution of exponential with mean theta. So here xi are IID fx comma theta, and xi square is also IID exponential with mean theta, because if we know if x, y are independent random variables, then fx and fy are also independent random variables for a function f. So now we use the transformation to xi square by theta, which will give us exponential 2, and we consider that exponential 2 is similar as chi-square 2 distribution because the two PDFs are same. So by uniqueness, we can say that exponential 2 are and chi-square 2 are the same distribution. So we define our statistic to be not statistic. We define a random variable as 2 by theta summation I equal to 1 to m xi square, which is following a chi-square 2m distribution. So now we have, from the property of chi-square distribution, we have, this is the chi-square distribution. So this is the upper 101 minus alpha percentile, and this is the lower alpha percentile. So this area is alpha by 2. This area is also alpha by 2, and this area is 1 minus alpha. We need to find these 2 points. So for chi-square 2m distribution, this point is chi-square 1 minus alpha by 2 2m, and this point is, as per our notation, chi-square alpha by 2 comma 2m. So our statistic t will lie between this interval, and that probability will be 1 minus alpha. So we can place the value of t here and can adjust the interval as 2 into summation xi square equal to 1 to m divided by chi-square alpha by 2 to m, and 2 summation xi square equal to 1 to m chi-square 1 minus alpha by 2 to m. The probability that this interval contain theta is 1 minus alpha. So we have got the alpha percent CI for theta based on x summation xi square. Okay. So here alpha is 0.02, as we have to find 98% confidence interval, and the number of sample size is 18, m equal to 18. So hence 2 into summation xi square divided by chi square alpha 0.01 on 36, and 2 into summation xi square equal to 1 to 18 chi square to 0.99 colon 36 is the 98% confidence interval for theta. Hence, option A is correct. This is all for today. Thank you for watching. I will see you in the next video. Stay blessed and stay tuned.